Welcome, ladies and gentlemen. Welcome to your video lesson on lesson 11.2, solving systems of equations by using substitution. So let's get right into it. This is your warm-up problem that relates to last class. Last class, remember, we were solving systems of equations by graphing. So the whole point was to look at a coordinate plane, graph two lines, see where they intersect, and observe that x comma y coordinate point, and that is the solution to our system of equations. So I'm going to go through the first one with you, and then we're going to relate this system to what we're going to do today. So at the end of the day, we are going to learn a brand new method called substitution, and we will not be graphing at all. We'll be able to find the same exact answers without graphing. That's the goal. All right. So you should remember from previous lessons that if I have an equation that is x equals a number, that is a vertical line through whatever the number is, right? So in this case, it's 8. And so 8 is right here on the x-axis. And so I will draw a vertical line through 8. And there it is. All right. Now, this one is in standard form. So when it's in standard form, you have two options to graph. You can use the intercepts method, or you can solve it for y and graph in slope-intercept form. So I will use the intercepts method here just to kind of review that with you. Remember, if you're finding an x-intercept, 0 is going in for y. So -4 times y is 0, so I'm left with just 3x is equal to 12. And if I divide both sides by 3, I get x equals 4, and then the x-intercept is 4 comma 0. So 4 comma 0, 1, 2, 3, 4 is right here. I'm finding a y-intercept. Remember, y or 0 goes in for x, and so I have -4y is equal to 12 because 3 times 0 is just 0. Okay, and then I'm dividing by -4, and I get y is equal to -3. So my y-intercept is 0, -3, which is down here. And now, if I'm going to complete graphing this, I want to figure out maybe how to get from this point to that point. What do? I go up 1, 2, 3, right? 1, 2, 3, 4. And I keep doing that. 1, 2, 3, 1, 2, 3, 4. And voila, there is the solution to my system of equations where the two lines intersect. That point is 8 comma 3. Okay. Now, on this page, I have the same thing done, but what I did is if you wanted to solve it for y, you get this equation here, and then our slope would be 3/4 x, and our y-intercept would be -3, just like we found the y-intercept to be -3 before. We get the same exact answer, so I wanted to bring that back to you. My question for you is, what if I give you the same exact information, and I was like, okay, how can you use this information to find the value of y? Okay, so let's ignore the fact that we're talking about system of equations. Let's ignore the fact that we're graphing anything. How can I just straight up use this information to find the value of y? The answer is this. Well, if I tell you that x is equal to 8, can I substitute 8 into that other equation and then just solve for y? And the answer to that question is yes, I can. Right? It would start off by looking like this. So 3 times 8 minus 4y would be equal to 12. And we would be able to solve this equation for y. That's what we would get. 3. We'd get 3. And guess what we already know x is? We know that x is 8. And so I know that this is a kind of a cheap preview here, but this is exactly what we're going to be doing in today's lesson. We're going to be taking one equation and substituting it into the other one to solve for a variable. Then once we get that answer, we'll substitute that answer into the other equation to find the remaining variable. So substitution is the method we're learning today. All right. So again, like I've been saying all along, 11.2, substitution is the lesson here. I'm going to actually skip this because we're going to just come back to it at the end. I think it makes more sense to do that. So we're just going to straight up get into some graphing, and then we're going to connect it to what we already know about some substitution stuff. So if I ask you to graph this equation, y equals x plus 4, you should all know that 4 is my y-intercept, 1, 2, 3, 4. My slope is 1, so I will go up 1, right 1, and I continue to do that, right? And we know from graphing that the more points I put on the graph, the more accurate I will be. I'll try to graph this as accurate as possible. There we go. All right, so that is the first line. I'll use a different color for the second line. I'll use green. Now, I showed the intercepts method. I'll solve this one for y this time. So I'll subtract 2x minus 2x, solving for y. That'll give me 2y is equal to negative 2x minus 12. And now I have to divide by 2. And I get y is equal to negative 1x plus negative 6. All right, so I'm going to go ahead and graph my minus 6 on the y-axis. So 1, 2, 3, 4, 5, 6. And my slope is negative 1. So I'll go down one, right one, down one, right one. But I'm going away from that other line. So I go back the exact opposite way. And right there is my answer. So the answer to the system of equations, again, another graphing method is negative 1, 2, 3, 4, 5, negative 5, comma, negative 1. Okay? And so that is the point where both those lines will intersect. So the question is, how can I solve this without graphing? And the answer lies in the conversation that we had way back in this problem here, where I said, okay, well, if I know that x is equal to something, I can substitute that something into the other equation. Well, don't we really have that situation here? Except for now, instead of like x equals something, I have y equals something. So I can, and we will, substitute that something in for y into the other equation. It's going to be slightly more complicated than we did last time. So let's try that method out in example 3. Okay? In fact, you know what? We're going to do that in example 3. My bad. All right. So here are steps for solving systems of equations. Step 1 says to solve at least one equation for one variable if you need to. And then if you do need to, pick the easy one. This part here we'll get to in later problems. All right, so let's take a look at and see if we have to do step 1 in this problem. It says solve one equation for one variable. What I actually have an equation, both equations are solved for one variable. So they're both solved for y. I do not need to do any of step 1 here, okay? Step 1 in this particular problem, I don't have to do. Step 2 says substitute that equation into the other one and solve for either x or y, whatever is left, right? This is what that looks like. Y is equal to something, so that something will be substituted in for y. So literally, I'm going to do that. So instead of y in this equation here, I'm going to have 2x plus 2 is equal to 8x minus 1. And now, in terms of like what we said here in this step, now we're going to solve for x because that's the only variable that's left here, okay? Now, solving for x first requires, like this step here, this is step 2, by the way. Step 2 requires the most algebraic work, solving equations. This is something we learned earlier in the year. The first thing I got to do is get all the variables on the same side, right? So I'm going to subtract the 2x from both sides. That gives me 2, because the x's cancel out, equals 6x minus 1. Okay, so solving for x again, what's happening to x is being multiplied by 6, and I'm subtracting 1, so I'm going to add 1 to both sides. So I get 3 is equal to 6x. And now my last step is to divide by 6. Now I don't get a very nice number here, but that's okay. I end up with x is equal to 0.5 or 1/2. All right. Now, I actually find the point where these two lines intersect. Remember, that's the whole goal, right? In a system of equations is to find where the lines intersect. The answer is no. I only have the x value. Now I got to find the y value. So what does step 3 say? It says take your answer from step 2. So in our case, it was x equals 1/2. Take the answer from step 2 and substitute that answer into the original equation and solve. So what I can do here is now take this 1/2 and substitute it in either this equation or that equation. It makes no difference. Okay, so step 3 over here. This is another opportunity where you can just pick the easy equation. It doesn't make a difference. So to me, it looks like the top one's easier. So I'll go y is equal to 2. And then instead of x, remember I have to use 0.5 or 1/2 plus 2. So y is equal to half of 2 is 1 plus 2, y is equal to 3. So I get the answer of 0.5 comma 3. Okay, so that is where those two lines intersect. And so one thing I always want to do is go back to the graph here. So I have actually all of these problems graphed. And so if we look at the answer here for the system, Lotus, those lines intersect at 0.53. Same lines graphed right there. Okay? So that is our first example with substitution. Again, steps are solve at least one equation for one variable if needed. We didn't have to do that here. We substitute that equation into the other one and solve for x or y. In this case, it was x. And in step 3, it says whatever we get for our answer for step 2, substitute that back into one of the original equations and find the remaining variable. So let's take a look at example 2 here. Okay. Now, example 2, we don't have to do step 1 again. We don't have to. We know that y is equal to something. So whenever we have the situation, we can skip step 1 and go ahead and substitute right away. Now this looks different than the other one. Like the other one, we ended up with like some stuff equals to some stuff, right? This one's going to look very different, but it makes no difference in terms of what we do to solve, right? We still have to solve for the remaining variable. So I'm going to go ahead and label this step 2 because we're skipping step 1. And it'll be 2x plus 2. Now, instead of y, we write x plus 4. And that's going to be equal to negative 12. Okay? Now, notice we only have x left. So in this case, we'll be solving for x in step 2. So I'm going to go ahead and distribute. I got 2x plus another 2x plus 2 times 4 is 8 equals negative 12. Okay, I got to combine some like terms. 2x plus 2x is 4x plus 8 equals negative 12. So now I got a two-step equation. X is being multiplied by 4, and we're adding 8. So I'm going to undo the addition of 8 by subtracting 8. So I will have 4x is now equal to negative 20. My last step is to divide by 4, and I get x is equal to negative 5. Okay, so again, that's just the x portion of where these two lines will intersect. Now I got to go through step 3 and go ahead and find the y value. So if x is equal to negative 5, that means I can take that negative 5 and substitute it into either the top equation or the bottom equation. Pick the easiest one. In my eyes, I think the top equation is the easiest because it looks like there's simply just less work to do. So that's what I'll do. So for step 3, I'll have y is equal to, and instead of x, I'm going to write negative 5 plus 4. And then this is obviously going to be equal to negative 1. So where do those two lines intersect? The answer is negative 5, negative 1. Okay, so what did we do in this one? We knew that y was equal to something right off the bat. So we substituted that something, that x plus 4, into the other equation right there. And then it was just a whole bunch of solving. We had to distribute first, combine some like terms. Then we had a two-step equation to subtract 8 and divide by 4, and we ended up in negative 5. Once we got the answer to that question, the variable, we substitute that back into one of the other ones. We chose x here, and then found our remaining variable for what y was equal to. Okay, and again, going back to the graph here, what does it look like when those two are graphed? Boom, boom. There the two lines are that's graphed, and lo and behold, look, they intersect at 1, 5, just like we got. All right. So example 4, which variable in which equation will be the easiest to isolate and solve for? So these are examples of where you actually have to solve an equation for a variable to start. So basically what I'm saying is we have to do step 1 in these next examples here. Now, what I'll tell you is that there's kind of a skill that let me think of it this another way. There is some thinking you want to go through, first of all, before you start just picking any variable that you want, okay? And let me just show you what I mean. So in this top equation, if I want to solve it for y, for instance, let's just go through the motions here. 5y is equal to 2x plus 12, okay? I'll divide by 5, right? Divide by 5, divide by 5. Here's the problem with that. I get y is equal to 2/5 x plus 12/5, right? And now I gotta take this whole thing and substitute that in for y, and I have to distribute a 2 onto 2/5 and 12/5, and that is going to work, but it's gonna be awful with all of those fractions, all right? So that's not the way to go. Here's what you wanna do. If you ever notice a variable all by itself, that's the one you wanna solve for, okay? So I notice that x is all by itself, and I'm going to solve for that because when I do that, all I will have to do, I'll label this step 1 right away, is add 2y to the other side. So I'll end up with x is equal to 2y plus 3, and that looks a lot nicer than the 2/5 and the 12/5 or whatever we had before, okay? So make sure that whenever you choose will be nice to work with, okay? It doesn't matter what you choose. It just it's a lot easier if you choose nicely. All right, now that I know that I'm in the same position that I was in all the other problems, right? I know that x is equal to 2y plus 3. So I'm gonna take that and I'm gonna substitute it. I cannot go back into the original equation that I just used. I have to go into the other equation, which will be right here, okay? And now everything I do from here on out is exactly the same as what we did before. So I'm going to start with 5y is equal to 2. And now instead of x, it's going to be 2y plus 3 plus 12. And now I only have y, so I will now start solving for y. So I got to distribute a 2. That'll give me 5y is equal to 2 times 2y is 4y. 2 times 3 is 6 plus 12. I got some like terms to combine. I'll end up with 5y is equal to 4y plus 18. Now I got to basically get all the y's on the same side, so I will subtract 4y to do that, which is kind of nice because in the end, I'm going to end up with just a y, and that'll be equal to 18. That is the end of step 2. I got y is equal to 18, so now I have to take that y equals 18, and at this point, because I did step 1, I actually have 3 options where I can substitute that y. I can use any of the 2 original equations, or I can use the manipulated one. And this one hopefully is pretty obvious to see that it is the best one to use because now all I have to do is multiply 2 times y plus 3, done. The other ones involve more in-depth solving, which again will work, but the easiest way to go would be using the manipulated equation. That's what I'm going to do. Okay, step 3. X is going to be equal to 2 times, instead of y, I'm going to write 18 plus 3. X is then equal to 2 times 18 is 36 plus 3, and I get x is equal to 39. So my systems of equations, my solution is 39, 18. Now think about if we actually tried to graph this, okay? And our answer to our system was 39, 18. That's like way out in the graph. And so this is like a point I can make for you that like solving by graphing, yeah, it's easy to graph lines. However, this is like not a real great answer to graph, okay? So you'd have to make a huge graph, adjust your scale. It's not going to be fun. Here's what I'm going to encourage you to do. I'm going to encourage you to pause the video, to work on this one by yourself. I will tell you that this one will give you not great answers, okay? So take a second, pause, and work through the problem and see how you did when you come back. Okay, welcome back. Hopefully you tried this on your own, and if not, that's fine. You can follow along. All right, so hopefully you guys noticed that the easy variable to solve for here was x in the top equation. Okay, so that's what I chose. Oh, where did that ink go? Ah. I had this whole problem was worked out behind here. All right. All right, we're gonna do this right now, live. Sweet. I was hoping to save some time, and you know, it didn't work. So here's what we're gonna do. We're gonna work it out right now. All right. So I'm gonna solve for x in the top equation. So I'll have 2y minus x equals 13. Okay. Now to solve for x, I'm going to subtract 2y from both sides. This is step 1, by the way. And I'll have negative x is equal to negative 2y plus 13. All right. Now, x is not solved, it's not by itself yet. Okay. So we have to get rid of that negative. And how do I get rid of it? I have to divide it out. So I'm going to divide everything by negative 1. All that does is change the signs, right? So in the end, I have x is equal to a positive 2y minus 13. Okay. So now that I know what x is equal to, I can take that x value and substitute it into x in the other equation right there. So that's what we're going to do. So I can get rid of this now, I guess. I will end up with step 2, 25 minus 6 times, now instead of x, it is 2y minus 13 equals 7y. All right, this is a negative 6. So I will end up now by simplifying. I have to distribute first. I'll have 25 plus 6 times negative 2 is negative 12y. And then negative 6 times negative 13, I believe, is 78. I'm going to do that quick. 6 times 13. Yep, 78. And it's positive 78 because it's negative times a negative. And that equals 7y. Okay, I got some like terms combined here. 78 plus 25 gives me 103. Minus 12y equals 7y. And then the last thing to do here, 2 more steps. I'm going to add 12 to both sides. Plus 12y. I'll get 103 is equal to 19y. Divided by 19 is my last step. This one's kind of a beast. I told you guys that. So divided by 19. And we don't get a very nice answer. We get y is equal to 5.42. Not so super nice, but this is what we get. And that's okay. Now that I know what y is, I can start with step 3. And step 3 says to take the answer that we got in step 2, which is that, and substitute it into the other equations. Now, again, we have 3 options, right? The top 2 or the bottom one. I would highly recommend using the bottom one. That's what we're going to do. So we'll say that x is equal to 2 times the 5.42. And then we're going to subtract 13. So x is equal to 2 times 5.42 is going to give us 10.84, we'll say. And we'll subtract 13 from that, and we'll get negative 2.1, it's really 1/6 if we run around to the nearest tenth. So these 2 equations, these 2 lines will intersect that, negative 2.16, comma, 5.42. And there you go. And again, bringing it back to the graph, that's these 2 here. That's not those 2. I think I got a typo in that one. Nope, it's these 2 here. There we go. And that's what we get. So the negative 2.15 and the 5.42 is where those 2 lines intersect. All right, good deal. So moving right along here. I have another example that, again, I want you guys to try on your own. This one is here still. So go ahead, pause the video, try it on your own, come back, I'll show you what it is. Welcome back. Hopefully you actually tried that. All right, so hopefully you recognize that x is the easiest variable. Here's the thing. In this problem, there's no variable that's all by itself that is like screaming at you, solve for me, okay? So you have to think about what you would divide by. And the easiest thought process is just think about yourself, be like, all right, well, if I solve for x, I'm going to have to divide everything by 3. Well, that'll give me 4/3 and 5, but I don't want to use 4/3, so that's out. If I solve for y, I have to divide everything by 4. That'll give me 3/4, and 15 divided by 4 is not a good number, so that's out. If I solve for x in the bottom equation, I have to divide everything by 2. And that does work out because 4 divided by 2 works out and 10 divided by 2 works out. So that's what you'll see me doing here. I picked the bottom equation to solve for x. Okay, to solve for x, the first thing I got to do is add 4y to both sides. So we're doing that there. I get 4y plus 10 on the right side, 2x on the left. To solve for x, I then have to divide by 2. And then I get x is equal to the 2y plus 5. Once the x is equal to 2y plus 5, I take that and substitute it into the top equation right there. And so instead of x, I have the 2y plus 5 plus 4y equals 15. I'm just going to show this all to you now. In the end, we get y is equal to 0. Take that y, substitute it back into the other equation, and we get x is equal to 5. So our intersection here is at 5, 0. And again, connecting it to the graph. Not those two, these two. There's our intersection point of 5, 0. Okay. Moving right along here. All right, special cases. This is also supposed to have a slide. There we go. Special cases. So remember from last class, we had 3 different types of solutions, right? So solution 1 was that we had intersection, right? We have a coordinate point that is a solution. Solution 2 was that there are parallel lines and we have no solution, right? And solution 3 was that we actually, in fact, have the same line. We said there was infinitely many solutions. But what does that look like when you're solving algebraically, okay? So that's what we're going to do here. So I'm actually going to undo this and get rid of all that stuff. Okay, so take a look. I do not have to do step 1 in either one of these. I know that y is equal to something, so I substitute that something into the other equation. So I have negative 6x plus 3 times, and instead of y, it's 2x minus 8. That is then equal to negative 24. Now check out what happens. When I distribute this 3, I'll get negative 6x plus a positive 6x, and then 3 times negative 8 is negative 24. That'll be equal to negative 24. Now what happens right here? Negative 6x plus 6x is just 0. So it's really gone. So what I'm left with is the negative 24 equals negative 24. When this happens, and it can, you have to evaluate whether or not this is true or false. And obviously this is true. So when we get a true statement, what we say is that that's the infinitely many solutions scenario, where these 2 lines are in fact the same line and they intersect infinitely many times. So let me show you what those 2 look like graphically. Get rid of this. There are the 2 lines, and notice you cannot see one from the other. So there's this one graphed, there's this one graphed, and when they're together, you can't tell them apart because they're the same line, infinitely many solutions. Okay, I have the next one already done for us. Whoops. So I'm going to get rid of that. And we go through the same exact steps, right? I know that y is equal to 3x plus 1, so I'm substituting that in here. I distribute to get a 6x, and 2 times 1 is 2. And I have the same exact scenario. Now, not every problem is going to have the same exact outcome. In this case, it's like the 6x's cancel out, right? It's just coincidence here. But what we are left with is the 2 equals 8, which obviously is not true, right? So in this case, we get a false statement, which means we get no solution. And this is the parallel line scenario. So again, connected to the graph, I have them graphed here. And when you look at them, you can see that they're parallel, they never intersect. Okay? All right. Last problem. So this one, Cameron. This is the beginning problem that we skipped because we knew we'd talk about it at the end. Cameron has $450 and saves $12 a week. Sean has $290 and saves $20 a week. Set up a system of equations that represents the situation given the information, using M for the amount of money that they're going to save and W for the number of weeks it's going to take them. So after that, we're going to solve that system and we're going to find out after how many weeks will they have the same amount of money. This is a scenario which like one person has a lot of money, but they're saving a little. Another person has a little amount of money, but they're saving a lot. So eventually their paths will cross. We want to know when that's going to be. So I have an equation set up for Cameron here. Cameron's equation is M for money is equal to the $450 that he already has plus 12 per week that he's saving. Sean's equation is starting with the same M for money he has. Plus the 2 is equal to the $290 that he's already saved, but he's saving $20 per week. And so this is a scenario that we would use for substitution for. Notice we're not using X or Y here, but it really doesn't matter. If we were to do that, I would probably be like Y is equal to 450 plus 12X. Okay, but we're not doing that, and it's not a big deal. In any event, I know that M is equal to something in one equation, so I can substitute that something into the other equation right there. And so obviously that's what I'm going to do. So essentially what we're doing is like we're setting these two things equal to each other, right? So we got the 450 plus 12W equals 290 plus 20W. So I'm just going to go through the work to solve for W, subtracting W from both sides there. That'll give me 450 equals 290 plus 8W. I then have to subtract 290 from both sides. That gives me 160 is equal to 8W. Then I divide by 8, and I get W equals 20. What that means is that after 20 weeks, they will have the same amount of money. Now I just need to know what M is to figure out how much money that is. Okay, well, if W is 20, I can substitute that in for, I picked the top equation. I believe I picked the top equation. It doesn't really matter. No, I picked the bottom equation, but it makes no difference, right? So M is equal to the 290 plus 20 times 20, which is 400, plus 290, which gives me $690. So in the end, what does that mean? That means that after 20 weeks, they will each have $690. All right. So ladies and gentlemen, independent practice. There's a lot of work that is done with these problems. We didn't give you too many, just enough for you guys to get some practice, okay? So 11.2, 1 through 5, 8, 9, 18, get it done. Adios.